The overall goal of the following experiment is to fabricate silicon nanostructures with traceability to the atomic lattice using direct metal oxide etch mask growth and reactive ion etching. The ultimate precision of this procedure involves removing precise areas of a hydrogen passivation layer on a silicon chip using a scanning tunneling microscope tip. As a second step, the patterned surface is exposed using an atomic layer deposition process that selectively deposits titanium dioxide and acts as a mask against reactive ion etching. Next, reactive ion etching is performed in order to remove silicon from the surface in all areas except those that had been patterned previously. The results show the ability to fabricate up to 20 nanometer tall structures with critical dimensions well below 10 nanometers.
The main advantage of this technique over more conventional methods like e-beam or optical lithography is that the initial metrology steps in the STM provide atomic scale information. This method can help answer key questions in nanotechnology, such as what are the precise interactions between nanostructures placed at very well-defined positions relative to each other.
Generally, individuals new to this method will struggle because there are so many steps and opportunities to damage the sample.
So we first thought of this method when we were trying to maximize the thickness of silicon dioxide etch masks, which we were writing on silicon using an AFM and an STM tip in an oxidizing atmosphere. Instead, by combining hydrogen lithography with atomic layer deposition, we were able to obtain a similar aerial control while actually gaining a greater degree of freedom in the growth.